So for 85, it's sort of a strange function because we've got an input variable of s, which is a little different. Usually we use x or t, but it could happen, I suppose. But the main thing is going to be what happens when we put in the negative version of that input. What do we get out? So let's try that process. And what I find best is to convert this to a radical. That's what I think is easier. It's probably going to be what you're more familiar with doing. So that's the approach I'm going to take, and that should get us there pretty quickly. So if we did a radical, you raise the variable to the power of the numerator, you take the root of the denominator. So it's going to be cube root of negative s squared. Okay, well, that being the case, negative s squared will become positive s squared. And we'll keep the cube root, it's times 4. Well, now that that's positive 2 inside the radical, we could convert it right back to a rational exponent form. And positive 2 over 3, so positive 2/3. All right, I think we've converted as far as we can go on this one now. But the point is, it looks just like the original. So that tells us this is an even function. So I usually get all kinds of questions about this one. This actually becomes one of the main ideas in calculus. If I had to name the 3 main ideas that I remember from calculus, this is one of those. I mean, I'm talking like the 3 main branches calculus gets into. So this is a huge idea. It's something you really need to make sure you understand. So let me kind of talk you through what you're looking at, because it's kind of overwhelming. You've got a piece of a parabola. We've got a domain restriction, so you just see a little bit of it. There's the equation for that parabola. You've got a constant or horizontal line, and that equation is y equals 2. They didn't give you this. Hopefully you can kind of interpret that just by looking at the graph. The bottom of that shape is going to be a 2, it's a flat line. So you do need to know that the constant function y equals 2 is happening there. They did give us a couple points. They gave us a starting and ending point, 1, 2, and 3, 2. And they told us to find a function for the height of this bar. The idea is this bar could move around and its height would change depending on what x value you put in. So I think in the book they had a little dotted line showing x, showing that whatever the x value is, that's the left side of this bar. I put a little dot there we're going to talk about in a second. And what's the height of the bar as x changes. So if you put x right here in the middle, that's 2. That's about as tall as that bar can be. But if you got the x value closer to 3 over here, this bar would be really small. So the bar is going to change depending on where you go along the curve. So let's try to define what the edge of this bar is going to be. How can we define this point? So it's going to have an x coordinate. That's the first part. And if we're going to write a function for how tall this bar is, then it's going to be a function of x. And I'm going to use h here. You can use whatever you want. Since we're talking height, I think that makes sense, and it's pretty common, something you'll see. H of x is the way it's given a lot of times. So whatever this point is, and I'm leaving it that way because it could change. X could be anything from 1 to 3. And that would tell you that the height of that bar would change. What we're going to do is create a function so that we can get the exact height of this bar, just knowing the position we are on the x-axis. So I guess the next step now is to think about how would you find the height of this thing. So we probably need a second point on the edge. If you want to find the height of the bar, well, you need to find the distance between these 2 y values. So if this was, say, instead of h of x, let me just say y1, and this point is, say, x2, y2. It didn't come out real clear, but that's supposed to be y2. Well, if that's y1 and this is y2, I need to subtract those to figure out the height. So height would equal y1 minus y2 in this case. Whatever this y-coordinate is minus this y-coordinate, that's the height of the bar. That will change depending on where we are on the curve. So if you think about it in terms of the two functions, well, here's this parabola is one function. So let's call that function 1. So I'm going to put a little 1 here underneath the y so we can see that's our first function. And the bottom part, it's always going to be 2, but this y value, this y2, well, can be given by that constant function where it's always 2. So now you've got a function that you can get the exact value of this y coordinate and the exact value of this y coordinate. This one's always 2, so that was pretty straightforward. But this one will definitely change as x changes. So now if you start kind of putting this together, well, height is the y coordinate here minus the y coordinate here. And we can find that y coordinate exactly using this function. We can find this y coordinate exactly using this function. So you just have to do a little substitution. Just substitute y1 in here, y2 in here, subtract them, and that's going to be your function. So your height function is going to be, again, y1, plug it in, negative x squared plus 4x minus 1 minus your other function, which is just 2. And put those two ideas together, simplify what you can, and we're going to get negative x squared plus 4x minus 3.